Okay guys, so there's one more lesson for today, and it's for 3.5 part 2, which is absolute value inequalities. So when you see an absolute value inequality, it's a lot like an absolute value equation, but there's a symbol difference. For example, I could show you the absolute value of x is less than 2. So you can tell whether something is a less than symbol because notice the arrow is going to point to the left. That's how you know it's a less than symbol. If you were to look at that in terms of a number line, what they are asking you for is for all numbers on the number line where the distance from 0 is smaller than 2. So here's what I recommend that you do. You are definitely going to break it out of jail, but before you do, you have to decide if this is an and inequality or an or inequality. The way you can tell is by looking at the sign. If it is a less than symbol, it is an and equation, meaning that you have to satisfy both inequalities. When you break it out of jail, one turns to the good side, so you just recopy exactly what you see without the absolute value bars. So x is less than 2. When you go to the other side, you remove the absolute value bars. You need to flip the inequality sign the other direction, and you need to change the answer to a negative. So you'll now have two inequalities. X is greater than negative 2, and x is smaller than 2. I recommend that you graph this on a number line. So remember that 0 always goes in the middle. Negative 2 should be on the left of 0, and positive 2 should be on the right of 0. You want to simultaneously be larger than negative 2 and smaller than positive 2. So that would be everything that is between the two of them. So you would shade everything between negative 2 and positive 2. And then you have to decide whether you use a parenthesis or a bracket. Again, this is based on the symbols. If it is not an inequality with a line underneath, then you will use a parenthesis. Now, they will often ask you to write this in interval notation. So in interval notation, you will say that you have shaded everything from negative 2 to positive 2. If they ask you to write this in set notation, you will use your curly brackets. You always start with an X and a bar. And you will say that X is trapped between negative 2 and positive 2. So you write the X in the middle. You write the less than 2 on the right, and then you write the negative 2 on the left. And notice that the x should be the larger, that the alligator is eating the x. This is an example of an and problem. Let me show you an or problem. So let's do a very similar absolute value. The absolute value of x is greater than or equal to 2. So notice that it is a greater than sign. So whenever you are dealing with a greater than sign, it is going to be an or problem. So I always tell people less than is and, greater is or. So again, you're going to break it out of jail. Some turn to the good side. X is greater than or equal to 2. Some turn to the bad side. X is less than or equal to negative 2. So notice you need to flip the inequality and change the sign. If you don't do both, then you're going to get it wrong, okay? All right, your x is already alone, so there's no solving necessary. So let's put it on our number line. So we're going to draw our number line. Zero goes in the middle of our number line. Positive 2 goes on the right. Negative 2 goes on the left. Now in this scenario, we want x's that are smaller than negative 2, so that would be to the left of negative 2. Or we want x's that are larger than positive 2, so that would be x's that are to the right of 2. Then, because the inequality has an equal sign underneath, you need to use brackets in this problem. And then to state that in interval notation, you go from left to right. So since you have two chunks of shading, you're going to have two chunks of interval notation. So the furthest to the left you go is negative infinity. Infinity symbols always get written next to a parenthesis. Then you travel along till you hit negative 2. Negative 2 uses a bracket. You use a union symbol since you have more than one shaded region. The right of your second region is 2 with a bracket, and you go to infinity, so comma infinity. That would be your interval notation. Set notation, again, you use your curly brackets with an X and a bar. And in set notation, you can just copy what you had up here. So you have that X is smaller than negative 2, or X is larger than positive 2. And that would be your set notation. Okay, so let's make it a little more in-depth, okay? So let's say that I gave you the following problem. The absolute value of 5x minus 2 is greater than 13. So again, you want to make sure that your absolute value is isolated. It is. You want to make sure that you're dealing with a positive number so that you don't have the no solution situation. You are. Then you want to decide if it is an and or an or problem by looking at your symbol. This is a greater problem. Greater is or. Then you want to break it out of jail. So put the good guy on the right. 5x minus 2 is greater than 13. Put the bad guy on the left. 5x minus 2 is less than negative 13. Then we need to solve each of the inequalities. So we need to get rid of the minus 2 with a plus 2. So 5x is less than negative 11, or 5x is greater than 15. Then we need to get rid of the 5's with division. X is smaller than negative 11 fifths, or x is larger than 3. Don't let the fraction freak you out. It doesn't mean anything's funky. It just means you're going to have fractions in your answer. Once you have the answer solved, then you need to put it on a number line. 0 is in the middle. 3 is on the right. Negative 11 fifths will be on the left. Negative 11 fifths is a little bit more negative than negative 2. You want x's that are smaller than negative 11 fifths, so that will be to the left of negative 11 fifths. You want x's that are larger than 3, so that will be to the right. Because there's no line underneath the inequality sign, you're going to use parentheses on that number line. So in interval notation, you will say that you went from negative infinity to negative 11 fifths, union 3 to infinity. So you always go from the left to the right. And infinity symbols always use parentheses. In set notation, you will use your curly brackets with the x bar, and then you're just going to recopy your last line. X is less than negative 11 fifths, or x is greater than 3. You have to know which version you are using because the answers will go back and forth. Okay, so let's try one more. Let's try this one. The absolute value of negative 3x minus 3 divided by 9 is greater than or equal to 1. Okay, so let's roll through everything. Is your absolute value alone? Yes, so you can continue the problem. Is the answer positive? Yes, you can continue the problem. So then we need to break it out of jail. So you have to decide if it's an and or an or. Again, this is a greater, which is an or problem. Some go to the good side. Some go to the bad side. I'm not a big fan of the fraction, so I'm going to get rid of the fraction by timesing both sides by 9. And that's just my preference. If you want to keep it in there, keep it in there. When you times both sides by 9, the fraction will cancel. So you will have negative 3x minus 3 less than or equal to negative 9, or negative 3x minus 3 greater than or equal to positive 9. Now we need to solve for x, so we're going to need to add 3 to both sides. Negative 3x is less than or equal to negative 6, or negative 3x is greater than or equal to 12. Now here's where you have to be very careful because this is a special rule. In order to solve for your x here, you need to divide by a negative 3. Well, this is a rule that you are supposed to remember from your previous math class, whatever that was. This rule says that whenever you multiply or divide by a negative number, you have to flip the inequality sign. So because I'm getting ready to divide by a negative 3, my less than or equal to symbol is going to become a greater than or equal to symbol. And negative 6 divided by negative 3 is going to become a positive 2. Again, on the other side, because I divided by a negative 3, my greater than or equal to sign is going to become a less than or equal to sign. And positive 12 divided by negative 3 is a negative 4. Now, graph this on the number line. 0 goes in the middle. Positive 2 should go on the right of 0. Negative 4 should go on the left of 0. And in this problem, we want x to be greater than 2. We want x to be smaller than negative 4. Because they have the equal to sign, we are going to use brackets here. So in interval notation, we would write this as negative infinity to negative 4 bracket union positive 2 bracket to positive infinity, just like that. Let's do one more and problem just to make sure you got it. How about this one? 2 times the absolute value of x plus 1 minus 1 is less than 3. First thing you would do is make sure your absolute value is alone. Our absolute value is not alone, so we would have to undo the minus 1 with a plus 1 to both sides. 2 times the absolute value of x plus 1 is less than 4. Our absolute value is still not alone because of the 2, so we will have to divide both sides by 2. The absolute value of x plus 1 is smaller than 2. Now that our absolute value is alone, we need to decide if this is an and or an or problem. This is an and problem, so now we can break it out of jail. X plus 1 is smaller than 2. X plus 1 is greater than 2. Now we can solve each side of the equation by doing, oh sorry, I dropped my negative on that too, by doing a minus 1. X is greater than negative 3, and x is smaller than 1. When we go to put that on the number line, 0 goes in the middle, 1 goes on the right, negative 3 goes on the left. Because we want to simultaneously be larger than 3 and smaller than 1, we will shade in between them. And since there's no equal to signs underneath, we use parentheses. So in interval notation, we will have parenthesis negative 3, comma 1 parenthesis.